Welcome to the deep dive. This is where you send us the stuff you're reading, watching, listening to, and we try to boil it down to the essential knowledge, those moments that make you go, aha.
Exactly. And today's dive, it's into a really fascinating and honestly quite powerful area, using Python and JavaScript for, well, security exploration and hacking concepts.
Right. So our listeners shared some great material. We've got bits from Black Hat Python, JavaScript for hackers, and also Violent Python, a cookbook.
A potent mix.
Yeah. And our goal here is to pull out the core ideas, the practical uses of these languages in a security context. Think of it as maybe a shortcut to getting your head around some pretty complex topics.
We'll be looking at how Python helps with things like, mapping networks, trying to crack passwords, analyzing network traffic.
And then we switch gears to JavaScript, right? Looking at web reconnaissance and some, frankly, really surprising security angles you might not expect from JavaScript.
Definitely some unexpected stuff in there.
Okay, let's get into it. Starting with Python, using Violent Python as a guide. The first thing that jumps out is just how accessible Python is, but also how powerful for these security tasks.
Totally. It's not some obscure language. You can find installers easily. Windows, Mac OS, Linux.
And it's often pre-installed on Mac and Linux anyway, right?
Yeah, chances are it's already there. That ease of access is, well, it's pretty crucial.
And it's not just the language itself. It comes with a huge standard library.
Oh yeah, a massive collection of tools ready to go. And adding more specialized ones is simple. You just use the Python package index, pypi.python.org.
Right, like pip install something.
Exactly. Pip install, and you've likely got the tool you need for, say, network stuff or whatever. Usually gets you sorted.
Okay. And for people maybe newer to coding, Python's interpreted. How does that work compared to like compiled languages?
So think of it like a live translator. It reads and executes your code line by line, more or less. You can even type commands directly into an interactive session and see results immediately.
Ah, okay. But for repeatable tasks, you save it in a script, a .py file.
Precisely. You write your steps in a .my file, and then you tell the Python interpreter to run that whole script.
Gotcha. The source, Violent Python, mentions the sys module early on. What's that for?
Right. Sys is key for flexibility. If you want your script to, say, target a specific IP address you type in when you run it, or maybe process a specific file.
Like command line arguments.
Exactly. Sys.rgv lets your scripts grab those arguments you provide on the command line. Makes your tools much more usable.
And then there's the os module. That sounds like it talks to the operating system.
It does. It lets your Python code do things like check if a file exists before trying to open it, or see if you even have permission to read it. It's about connecting your script to the system it's running on.
Okay, so those are the fundamentals, setting the stage. But this is where it gets really interesting, right? Applying this to actual security tasks.
Absolutely. Let's move into those practical applications. Both Violent Python and Black Hat Python really dig into using Python for network scanning.
Network scanning, like finding what's out there on a network.
Yeah, basically identifying active devices and what services they're running. A big part of that is port scanning, checking which communication channels or ports are open on a target machine.
Ports are like specific doors for different applications.
Good analogy. Different services listen on different port numbers. And Python lets you check those doors. The source mentions TCP SYN scans versus TCP connect scans.
Okay, what's the difference there?
A SYN scan is sort of like a quick knock. You send the initial connection request, SYN, but don't complete the full handshake if you get a response. A connect scan goes through the whole process.
This one's maybe a bit quieter.
Potentially, yeah. And Python's built-in socket module gives you the low-level control to actually craft and send these kinds of packets.
But there are libraries to make this easier, I assume.
Oh, definitely. The source mentions the Nmap Python library. Nmap is a really powerful, well-known command line scanner.
Right, I've heard of Nmap.
Yeah, and this library lets you basically drive Nmap from within your Python script, so you can automate scans, integrate them into bigger workflows. The source shows a basic example, how to install and run it.
Okay, scanning makes sense. What about brute forcing? That sounds more aggressive.
It is. It's about systematically trying passwords or keys until you find one that works. SSH, the secure shell for remote login, is a common target example.
And Python can automate that.
Yep. Violent Python introduces a library called ps-esh. It lets your Python script interact with an SSH session, like sending commands, entering passwords.
But wait, isn't brute forcing SSH passwords kind of hard nowadays with lockouts and stuff?
You're right. Modern SSH setups often have defenses. Multi-factor authentication is huge. Strong key usage is vital. So simple password brute forcing against a well-configured server is less likely to succeed. But understanding how it works, programmatically interacting with the protocol, is still valuable.
Okay, so it's a learning exercise too.
Exactly. And the source also mentions exploiting weak private keys. If someone doesn't protect their SSH key properly, you might not need to guess a password at all.
Ah, I see. And it applies to other things too, like FTP.
Yeah, the text touches on FTP brute forcing as well, using Python's built-in ftplib. It shows the principle applies to different services if they lack proper security.
Okay, moving from breaking in to gathering information. Web reconnaissance.
Right. The web is just a massive source of info, and Python is fantastic for automating collection. Web scraping is the term.
Using libraries like Mechanize, is that mentioned?
Yep, Mechanize is mentioned for automating the process of fetching web pages, almost like controlling a browser programmatically.
But web pages are messy, right? All that HTML code?
They are. And that's where Beautiful Soup comes in. It's a library specifically for parsing HTML and XML, making sense of that structure.
So you could use it to find all the images on a page or links or specific text?
Exactly. Find all the MG tags and grab their SRC attributes, for instance. The source also mentions interacting with Google search results via Python, and even pulling data from Twitter's API, using things like JSON and urlib to handle the data.
Okay, this next one sounds fascinating. Packet sniffing and analysis.
Yeah.
Like listening in on network conversations.
Pretty much, capturing the raw data packets flying across the network and then dissecting them. Python libraries like dpkt and the very powerful Scapy are the tools for this.
And what can you actually find by doing that?
Well, if the traffic isn't encrypted, the sources mentioned potentially grabbing FTP usernames and passwords, seeing information about hotel guests on unsecured Wi-Fi.
Wow.
Even seeing what search terms people are typing into Google, it can be surprisingly revealing.
So analyzing the contents of those packets.
Right. You parse the data according to the protocol like HTTP or FTP and see what's inside.
And it gets more advanced. The source mentions DDoS attacks and fast flux.
Yeah, it touches on identifying distributed denial of service attacks by looking for patterns, like specific commands maybe being sent over IRC, which is sometimes used to control botnets.
Okay.
And fast flux is a technique where malicious sites rapidly change their IP addresses to avoid takedowns. Analyzing DNS traffic patterns with Python could potentially help detect that kind of activity.
So Python can be a defensive tool here too, not just offensive.
Absolutely. Understanding traffic is crucial for defense. These basic tasks, scanning, trying access, gathering info, analyzing traffic, they're really the building blocks for more complex security work.
Which leads us into actual exploitation concepts, moving beyond just information gathering.
Right. Violent Python and Black Hat Python start talking about using the info you've gathered. Client-side attacks are mentioned briefly, like finding a vulnerable FTP server hosting web files and injecting malicious redirects into those files.
Okay, so compromising the website visitors, not the server directly.
In that example, yeah. And then there's writing basic exploits. Python's simplicity makes it pretty good for quickly coding up a proof of concept for a vulnerability.
Even 0 days, vulnerabilities that aren't publicly known.
Potentially, yeah. The source uses a specific example, a stack-based buffer overflow, in an old FTP server called FreeFloat.
Buffer overflow, that's stuffing too much data into a memory space, right?
Essentially, yes. You send more data than the program expects for a particular variable or buffer. If you're careful or lucky, you can overwrite other important data in memory, potentially even the instruction pointer, which tells the program what code to run next.
Letting you run your own code. Scary stuff.
It highlights why secure coding practices, like checking input links, are so critical.
And the last Python bit mentioned is Windows privilege escalation, getting more power on a Windows machine.
Right. Going from a regular user to an administrator, for example. The source mentions using Python, specifically the Win32 security module, to check what privileges a running process has.
Like Debug privilege. What are those?
Things like cbackup privilege allows backing up files, even restricted ones. Cdebug privilege allows inspecting and debugging other processes. Cload driver allows loading device drivers. These are powerful permissions.
And if an attacker compromises a process that has these privileges,
they could potentially leverage them to gain more control over the system. It's a common goal in post-exploitation.
Okay, that covers a lot of ground with Python. It really seems like a Swiss Army knife for security tasks.
It really is versatile, which brings up an interesting question. What other languages have unexpected security uses? And that leads us straight into JavaScript for hackers.
Oh yeah, this section was wild. JavaScript, you think, okay, website animations, handling forms, that kind of thing. But the security angles discussed here are, well, they're incredibly
It
clever.
really shows a different side to the language.
Let's start with Unicode exploits. Using special character codes in weird ways, even in variable names. How does that even work?
Well, JavaScript supports Unicode extensively. Sometimes these different ways of representing characters can bypass security filters that are only looking for standard ASCII characters, or they might be interpreted differently by different parts of a system, like a back end versus a front end. It's subtle.
Okay. Then abusing built-in objects. This one blew my mind. Overwriting value on the window object, the main browser window object,
Yeah.
to run code.
Yeah, it sounds crazy, sure. But JavaScript is very dynamic. You can often redefine parts of built-in objects. In this case, changing how value of op behaves for window could potentially trick some code that uses it into executing something else, like the example alert.
Wow.
Good.
How do browsers even defend against that?
It's tough. They use sandboxing, context separation, and other security layers, but the fundamental flexibility of JavaScript means creative attackers keep finding ways to abuse language features. It really emphasizes careful coding and understanding these edge cases.
And the creativity just keeps going, getting around character restrictions using throw and on error without parentheses.
Right, if a filter blocks parentheses, which are essential for calling functions normally, this is a technique to potentially trigger code execution anyway, by throwing an error and having an or error handler catch it and run code.
And even automatic semicolon insertion, how JavaScript adds semicolons itself, and using weird new line characters can mess with firewalls.
Sometimes, yeah. Web application firewalls, WAFs, often work by matching patterns. If you can subtly change the code structure using these language quirks, you might bypass a rule. It's this constant cat and mouse game.
Then there were tagged template strings and symbol.has instance. These sound like more advanced JavaScript features.
They are. Tag template strings process placeholders in a specific way that can sometimes be manipulated. And symbol.has instance lets you completely redefine how the instance of operator works for your objects. Imagine making an object pretend it's an instance of a completely different class that could lead to some very unexpected behavior.
Like rewriting the rules on the fly.
Kind of, yeah. And fuzzing parser behavior, trying slightly different ways of writing code, like varying whitespace, to see if different JavaScript engines or sandboxes interpret it differently. That's another angle. Finding those inconsistencies can sometimes reveal bypasses.
Okay, DOM clobbering. This sounded weird. Using HTML tags like anchor tags A to overwrite JavaScript variables.
Yeah, that's the idea. If you have a JavaScript variable in the global scope, say my variable, and you manage to inject an HTML element, like a drive my variable href some value, some browsers might actually make the my variable in JavaScript refer to the HTML element, and its value might be influenced by attributes like href.
So clobbering is like the HTML element stomping on the JavaScript variable.
Exactly, it takes over the name. If other JavaScript code relies on that variable having its original value or type, clobbering it can break things or, worse, lead to vulnerabilities.
And the source mentioned ways to control timing and bypass, quote, restrictions using style tags and at import.
Yeah, getting into more complex variations involving iframes and careful timing to make the clobbering happen under specific conditions, even when direct injection of quotes is blocked. Really intricate stuff.
Then cross-origin issues. Leaking information between different websites loaded in the browser. There was a Safari bug mentioned.
Right, a historical vulnerability where you could potentially change the perceived host name of a site loaded in an iframe, which could trick scripts or users. Also, using the constructor property to climb up the prototype chain and access the powerful function constructor, even in a restricted iframe, to execute arbitrary code.
And a Chrome info leak, too, with document.baseURI.
Yeah, another subtle issue related to how base URIs were handled in nested iframes under certain conditions, potentially leaking information across origins. These highlight how complex browser security and the same origin policy, SOP, are.
Okay, prototype pollution. This sounds serious. Messing with the fundamental blueprints of JavaScript objects.
It is serious. JavaScript uses prototypes for inheritance. If you can modify a core object's prototype, say object.prototype, you can potentially add or change properties that will then appear on all objects created afterward.
Wow, all objects, even built-in ones.
Potentially, yes. The source mentions this affecting even native browser APIs like Fetch, used for making web requests. And it's not just browsers. It discusses using Node.js debugging flags like inspect to find these vulnerabilities on the server side too.
That seems incredibly dangerous. One change affects everything.
It can be. It requires finding a specific gadget, a piece of code that improperly merges or assigns properties, but the impact can be widespread. It really forces you to understand JavaScript's inheritance model deeply.
And then generating JavaScript characters without letters or numbers, using array tricks, plus what even is that?
Yeah, that looks like line noise, but it's a technique often called JS-fuck or similar. By using type coercion and basic operators on empty arrays, Boolean values is false plus is 0, you can generate nan, undefined, numbers as strings, and eventually build up enough characters to access the function constructor, filter constructor, and run arbitrary code.
That's incredibly convoluted, but also kind of brilliant.
It shows the extremes people go to bypass filters that block alphanumeric characters.
Okay, nearing the end of the JavaScript section. Script injection bypasses. Just blocking script isn't enough.
Often not. The source points out that simply escaping the /script might seem like a fix, but techniques using HTML comments might still allow injection if you control 2 points in the output.
Ah, clever. And source maps leaking info. How?
Well, developers often use source maps to debug minified JavaScript. Browsers might request these .map files based on comments in the JavaScript. If these maps contain sensitive info or reveal source code structure, and if an attacker has an out-of-band way to see those requests, like controlling a DNS server, it could be an info leak.
And new ways to redirect users. Navigate.
Yeah, newer API in Chrome that can be used to trigger navigations, potentially including JavaScript.
Yeah.
URLs, offer another sync for cross-site scripting, XSS.
And SVGs executing JavaScript, even embedded ones.
Right. Scalable Vector Graphics, SVG, is an XML-based format, and it can embed scripts using an SVG image, perhaps via a use element or even a data. URL could be another vector for XSS if not handled carefully.
And finally, just various HTML events, like on-transitioned or even things on hidden inputs.
Yeah, there's a whole range of event handlers in HTML, on scrolling, on before toggle with popovers, etc., that can trigger JavaScript. Sometimes these can be triggered in surprising contexts or on unexpected elements, providing yet another avenue for execution.
Wow. Okay. That's a lot to take in for both Python and JavaScript.
It definitely shows the breadth and depth of how these languages intersect with security.
So wrapping this deep dive up, what are the big takeaways for you, for the listener? It seems Python is this incredibly versatile, accessible tool for all sorts of security tasks, right? Network stuff, automation, exploit basics.
Absolutely.
Yeah.
Its accessibility to libraries like requests, Scapy, Nmap, they make it powerful for both defenders and attackers. That accessibility, though, does that lower the bar in a potentially dangerous way?
That's a good question. It probably does, meaning more people can get involved in security research, which is good, but also potentially in malicious activity. Education and ethics become really important there.
Definitely. Responsible use is key.
And JavaScript. Wow, it's way more than just making websites pretty. The JavaScript for Hackers material showed just how many subtle, intricate ways the language itself can be bent or misinterpreted for security exploits.
That idea of overwriting value on window or prototype pollution or those character generation tricks, they really highlight that deep language understanding is critical for web security. It's not just about the surface level.
Yeah, I mean, some real aha moments for me were seeing Python used for password cracking attempts, even if conceptually the depth of network traffic analysis and just the sheer creativity in those JavaScript exploits.
It's a constantly evolving field. These sources give a great snapshot of both foundational techniques and some pretty advanced cutting-edge stuff.
So hopefully this deep dive gives you a solid base, a foundation for understanding these areas more.
Yeah, we really encourage you to explore further. Dig into libraries like Scapy or Beautiful Soup.
Yeah,
Read more about JavaScript's prototype chain or DOM clobbering. There's always more to learn.
definitely.
And maybe a final thought to leave you with. Considering how powerful and accessible tools like Python and the techniques in JavaScript are becoming, what parts of our digital world, what security areas are maybe being overlooked right now and deserve a much closer look?
That's a great question to ponder. Thanks for providing these sources. They were incredibly insightful, and thanks for joining us on the deep dive.
Always a pleasure. Until next time.